See, I told you that matter is composed of atoms and molecules, right? Now, what are atoms and what are molecules? You know, the basic difference between atoms and molecules is atoms have no independent existence. They cannot exist independently. It is because they are more reactive. Because they are more reactive, they just participate in the reactions and they cannot exist freely or independent. On the other side, molecules. In fact, atoms combine to form molecules. Now, molecules have independent existence. Sorry, molecules, yes, of course, have independent existence. It is because they are less reactive when compared to atoms. See the difference? Atoms are more reactive, molecules are less reactive. I can also tell you one more thing. Because they are more reactive, they are less stable. And because molecules are less reactive, they are more stable. Remember, stability and reactivity are inversely proportional. Okay. Then why do atoms combine to form molecules? You have answer here itself. Because atoms are less reactive. Sorry. Atoms are more reactive and less stable. Whereas molecules are less reactive and more stable. In order to acquire a stability, I mean from less stable state to get into a more stable state, isn't it? Everybody will actually try to acquire stability, even you also. You're all trying to acquire stability in your life by getting very good ranks in IIT, JEE, and NEET, right? That is the reason why you have come to me, you have come to our class. So any system generally tends to transform from a less stable state into a more stable state. That is the reason why atoms combine to form molecules. Okay. Next. Atom is the smallest particle of matter. I told you that elements are made up of atoms. And of course, compounds are made up of molecules. Now, this atom see, it actually consists of a nucleus at its center. Look at this. This is the nucleus. Okay. The nucleus consists of protons as well as neutrons. Then there is something else called electrons. Electrons revolve around the nucleus in the orbits. See, these are called orbits or shells or energy levels. We'll discuss in detail about all these later, but for the time being, remember, these are called orbits or shells or energy levels, in which the electrons will be revolving. See, these are electrons. Okay. Electrons revolve around the nucleus. Just as planets revolve around the sun. This was the proposal made by Rutherford. We'll discuss about all the atomic models later in atomic structure. But for the time being, remember, you got three fundamental particles. The first one is proton. The second one is neutron. The third one is electron. Okay. You know, nucleus is made up of protons and the neutrons, and these are collectively called nuclei. Okay. So there are three fundamental particles. One is electron, the other one is proton, and the last one is neutron. So these are called fundamental particles. Or you can also call them subatomic particles, because they are present in the atom. Subatomic particles. Okay. Next. Let me tell you something about the atom. You know, within the atom, we have orbits or shells. Yes. Now these orbits or shells are further classified into suborbits. You can also call them subshells. Just like shells, these are subshells or even sublevels. Now the suborbits or subshells are further classified into orbitals. See the difference? Now into these orbitals, we actually place electrons. So this is how the electrons are arranged in the orbitals. Orbitals are present in suborbits or subshells. Then, you know, the suborbits are present in Raven.
Sir.
Mute your microphone. Okay. Orbits into suborbits, suborbits into orbitals, orbitals are filled with electrons. So this is how the electrons are filled up in atoms. Let us see in detail about these things. Coming to the orbits. See, this is the nucleus. These are the orbits. Okay. Next. Now, supposing if, let us consider this You know, the orbits are represented by small n. This small n is in fact called principal quantum number. Okay, so when n is equal to 1, because it's the nearest, this is the first orbit, right? So when n is equal to 1, you know, we call it K shell. When n is equal to 2, look at this. It is called L shell. And when n is equal to 3, we call it M shell. And say when n is equal to 4, we call it L shell. Okay. You can even go for n is equal to 5. Sorry, this is n, no? N shell. And when n is equal to 5, it is O shell. When n is equal to 6, it is P shell. Like that, you can go on. So these are the orbits. Now, these orbits are further subdivided into sub-orbits or sublevels. You know, the sublevels are represented by small l. This L is called azimuthal quantum number, right? Orbits are represented by small n. Small n is principal quantum number. Now the sublevel represented by small l called azimuthal quantum number. Now let me tell you one thing. As I said, you got orbits in which there are sublevels. But what is the number of sublevels in an orbit? Let us see that. You know, the number of sublevels in an orbit is equal to n. I mean the principal quantum number itself. Let me give you example. Suppose the number of sublevels in the first orbit, I mean when n is equal to 1, you know, you will have just one sublevel. Only one sublevel, because number of sublevels is equal to small n. Here small n is equal to 1, therefore the number of sublevels is also equal to 1. And that's one sublevel, you know, is represented by small s. It is called S sublevel. Is that okay? If you want, you can write it as 1s. Now, how about the number of sublevels in the second orbit? N is equal to 2. Obviously, you will have two sublevels, right? Because it's the second orbit, you will have two sublevels. Now, the two sublevels are called 2s and 2p. Okay, so the number of sublevels in the first orbit is 1, and that is S sublevel. The number of sublevels in the second orbit is 2. They are 2s and 2p. Coming to the third orbit, you know, n is equal to 3. You will have 3 sublevels. What are they? 3s 3p, then 3d. SPD. Coming to the fourth orbit, n is equal to 4. You will have a 4 sublevels. They are, come on, 4s, 4p, 4d, 4f. Okay. Check out the things once again. Number of sublevels in an orbit is equal to n. In the first orbit, you have only one sublevel, that is a s. It is represented by 1s. Because it is present in the first orbit, we represent it this way. In the second orbit, you got two sublevels, 2s and 2p. In the third orbit, you'll have three sublevels, 3s, 3p, and 3d. Now in the fourth orbit, see, there are four sublevels, 4s, 4p, 4d, and 4f, right? Let me give you some more information. Coming to, when the value of L is equal to 0, we call it S a sublevel. I've already given the list of sublevels, S, P, D, and F. But for them, the values of L can be given as this. When L is equal to 1, we call it P sublevel. Similarly, when L is equal to 2, we call it D sublevel. Right. When L is equal to 3, we call it F sublevel. So L is equal to 0. Every single line is very important. The sublevel for L is equal to 0 is S sublevel. L is equal to 1 is P sublevel. L is equal to 2 is D sublevel. L is equal to 3 is F sublevel. L is equal to 4 is G sublevel. Like that, we can go on. Okay. We'll of course give you some more information under the heading orbitals. Now, as I said, sublevels consist of orbitals. Let me just give you clarity taking S sublevel. S sublevel consists of just one orbital. Let me give you a statement first. Number of orbitals in a sublevel in the sense in L. How many orbitals can be present in a sublevel? That can be given by the formula 2L plus 1. Come on. For S sublevel, we know that the value of L is equal to 0. So therefore, the number of orbitals can be given as, come on, number of orbitals for L is equal to 0 can be calculated using that formula 2 of 0 plus 1. So how many are there? Only one. That is what is represented here. You got just one box, one square, because orbital is represented by a square or by a box. Got it? So this is with regard to S sublevel. Now let us go for P sublevel. They're all very interesting. You have to be very careful. So what is the value of L for P sublevel? L is equal to 1, right? I've just given this. Now the number of orbitals possible. The number of orbitals possible can be given as 2 of 1 plus 1. So how many orbitals are possible? 3 are possible. So a p sublevel is made up of 3 p orbitals. Okay, this is a p sublevel. P sublevel has 3 p orbitals. You know, the 3 p orbitals can be given as px, py, pz. See, now I'm giving you the basic information. We'll go for more and more information with regard to all these things later in the next topic, that is atomic structure. But for now, I think you are getting maximum clarity. See, in the SS sublevel, you got just one orbital, right? Now that one orbital is what we have represented here in the form of a box. Whereas in P sublevel, yes, we got 3 p orbitals. Now the 3 p orbitals are px, py, and pz. Okay, so this is about s and p orbitals. The sublevels consist of orbitals. In the s sublevel, you got just one orbital, whereas in p sublevel, you got 3 p orbitals. Got it? Next. Let us go for the d sublevel. Come on, I think you got my point. Coming to the d sublevel. Right. Now, the value of L for a d sublevel, we know that it is 2. Therefore, the number of orbitals can be given as very simple. It is equal to 2 of 2 plus 1, right? Because it is 2L plus 1 formula. Then the number of orbitals is 5. Let me just show you that. You know, a d sublevel is made up of 5 d orbitals. This is the d sublevel. You got 5 d orbitals in this. Now, what are these 5 d orbitals? See, the d orbitals can be given as dxy, dyz, dxz, dx square 2 y square. Don't say minus. Dx square 2 y square. Then finally dz square. So these are the 5 orbitals present in a d sublevel. But for the time being, remember there are 5 boxes or 5 squares in a d sublevel. They are called orbitals, right? Now let us go for the last one. F sublevel. I hope you are all very clear about this. L is equal to 3. Now therefore the number of orbitals can be given as 2 of 3 plus 1, right? 2 of 3, 6, plus 1, 7. So F sublevel is made of 7 boxes or 7 orbitals. 1, 2, 3, 4, 5, 6, 7. Is that okay? So F sublevel has 7 F orbitals. Okay. Now what are the F orbitals? What are the 7 F orbitals? Let me give you that information. Come on. F x cube, F y cube, F z cube. 3 cube things. Next. Okay. Then go for 3 more. F x of y square to z square. F y of z square to x square. Then f of, fz of x square to y square. These are all very simple. Okay. Finally, there is, yes, f x y z. Okay, so that is about the orbitals in sublevel. I think it is very clear. S sublevel has just one orbital. P sublevel has 3 orbitals. D sublevel has 5 orbitals. F sublevel has 7 orbitals. Okay. Now let us check how to fill up electrons in these orbitals. Let us check that out. Now, the last step, that is filling electron. Come on. I can give you 2 interesting things here. First of all, the number of electrons that can be filled in a sublevel. Let us check this first. Sublevel. It can be given as 2 of 2L plus 1. Say, I think you can see that this is the number of orbitals, right? This number of orbitals is now multiplied by 2, because every orbital, can accommodate, every box, every square can actually accommodate 2 electrons. Look at this. The first electron and the second electron. The first electron is represented by this. This actually refers to clockwise spin of electron. And this is anti-clockwise. Okay. So this is how every orbital can accommodate only 2 electrons. Remember, a maximum of 2 electrons can be accommodated in an orbital. So that is the reason why the number of electrons is orbitals multiplied by 2. Let me give you examples, taking the same old S, P, D, and F. Let us take S sublevel. See, in S sublevel, I told you that you got just one orbital, right? This is the S sublevel in which you got just one orbital. Here we can write 2 electrons. So S sublevel has one orbital and this one orbital can actually accommodate only 2 electrons. Coming to P sublevel, p sublevel, I told you that it has 3 p orbitals. Okay. Now, how many electrons can be accommodated? Look at the way I'm accommodating. First, only one electron each. Then pair up the electrons this way. Of course, there are certain rules followed. We'll discuss about the rules later. For the time being, remember, you know, in a p sublevel, there are 3 p orbitals, which can accommodate a maximum of 6 electrons. Shall we go for the relation? Check out the relation. L is equal to 0, right, for S sublevel. Then the number of electrons can be calculated using that formula. Come on, use the formula. 2 into 0 plus 1. How about this? 2 into 0, 0 plus 1, 1 multiplied by 2. So you can accommodate 2 electrons. That is what I have shown. Even calculate in this way also. I mean, in this case also, L is equal to 1. Therefore, the number of electrons. Yes, 2 into 1 plus 1. Come on, this 2 into 1 is 2 plus 1 is a 3. Into 2, you got 6 electrons. Very simple. You got 3 boxes or 3 orbitals. Every box or every orbital can accommodate a maximum of 2 electrons. So 3 into 2 is 6. Hope this is clear. We'll go for the last 2 also, D and F. I am giving you so many interesting things. You need to be very careful. Come on, D orbital. Or say D sublevel first. We know that D sublevel consists of 5 d orbitals, right? Now the 5 d orbitals, let me show you that. These are the 5 d orbitals. Fill up the electrons in these orbitals. They have just placed 1 electron each in the orbitals. Now I am going to pair them up. So a total of 10 electrons have been accommodated. Let us check this with our formula. Say for a D sublevel, L is equal to 2. This can be given as 2 of 2L. L is a 2 now. So this is 2 of 4 plus 1, 5. How many are there? So this is 10. Right? You got the same. Using the formula, even using the boxes. Then finally the F sublevel. Let us check that also. We know that F sublevel consists of, come on, 7 F orbitals. Let us show that. One, 2, 3, 4, 5, 6. Total 7. Now, coming to the filling. Again, the same. Fill up just 1 electron in each orbital. Then pair up Okay. So how many are there? A total of 14 electrons are there in this. Come on. Okay. So 14 electrons have been accommodated. Now, let us just use the formula because L is equal to 3 for F sublevel. It can be given as 2 of 3 plus 1 because it is 2 of 2L plus 1. Come on. This is 6 plus 1 is a 7. So a total of 14 electrons can be accommodated. So this is the clarity that I wanted to give. Number of electrons that can be accommodated in a sublevel can be given by the formula 2 of 2L plus 1. Number of electrons that can be filled. Number of orbitals can be given by the formula 2 of L plus 1. I mean 2L plus 1 simply. Now let me also give some more clarity by taking one more formula. Check this out. You know, the number of electrons in an orbit, this is going to be much more interesting. Let us suppose n is equal to 1, right? Let me actually give you the formula 2n square. We'll check that later, but now, you know, when n is equal to 1, I mean, when we are considering the first orbit, we will have only one sublevel, that is a 1s. I told you no. 1s. Only one sublevel is possible. And say that S sublevel, we know that it is made up of one orbital. Look at this. 1s is a sublevel and this is an orbital. This is the orbit. And now I'm going to place electrons. 1, then 2. So the total number of electrons is 2. Okay. See that the number of electrons that can be accommodated in the first orbit is 2. Come on, use the formula now.
Yeah.
Okay. Using the formula 2n square, we can calculate the number of electrons that can be accommodated in an orbit. 2 into first orbit, so 1 square. Therefore, it is 2 because 1 square is 1, isn't it? So I have given maximum clarity taking the n is equal to 1. Let me give you something about the second orbit also. Come on, n is equal to 2. Yes, look at the things. Second orbit, we know that it has a 2s sublevel. It also has a 2p sublevel because look at the things. Second orbit, therefore 2 sublevels. I told you that the number of sublevels is equal to n. When n is equal to 2, you will have 2 sublevels. Now the orbitals information. Come on. 2s has just one orbital. We know that. And p will obviously have 3p orbitals. Right? Now just go on filling up the electrons. 2 here, then 1 each, pairing up. So how many are there? A total of 8 electrons. It is because here you got 2, plus in this you got 6. So a total of 8 electrons. The same can be calculated even using the formula 2 into, because this is the second orbit, let me go for 2 square formula. 2 into 2 square, 8. 8 electrons. Check this out. N is equal to 1. Orbit. Then orbit has, a total of 4 orbitals, 1 2s orbital and 3 2p orbitals. Isn't it? Here in this case, there is only 1 orbital. So in the second orbit, you got 4 orbitals, and finally you accommodated 8 electrons. So everything is, I think, crystal clear. Let us go for 2 more things, then that will be much more clear. Come on, N is equal to 3. Hope you all can imagine what I'm going to write. N is equal to 3. This is the orbit. Obviously, the number of sublevels is going to be the same, 3, 3s, 3p and 3d, isn't it? Now you got the number of sublevels. Third orbit will obviously have a 3 sublevels. Now orbitals. S sublevel will always have a box, only 1 box. P will always have 3 boxes. D will always have 5 boxes. Right? Come on. How many orbitals are there? 1 plus a 3 plus a 5. You got 9 orbitals, isn't it? Then the number of electrons. Come on, accommodate the electrons. 1, 1, 1. Then this, then this, then this. 1, 1, 1, 1, 1. Pair up, pair up, pair up, pair up, then pair up. So, we have accommodated a maximum of 18 electrons. Let me just give it clearly. 2 plus 6 plus 10. A total of 18 electrons have been accommodated. Now let us use the formula 2n square. Check whether we get the same or not. 3 square is 9 and 9 into 2 is 18. Yes, we got the same. I think this is very clear. Let us go for the last one. Come on, N is equal to 4. 4. 4 is the number of orbits. So the number of sublevels is going to be, yes, of course, 4. Because number of sublevels in an orbit is equal to small n. Okay, 4s, 4p, 4d. Of course, 4f, isn't it? So how many sublevels are there? Yes, there are 4 sublevels. Now let us go for the orbital. 1 in S, 3 in P, 5 in D, of course 7 in F. Check out. So you got a total of 1 plus 3 plus 5 plus 9. How many? 16 orbitals. Got it? Now let us fill up the electrons in these. 2, 1 each, then pairing them. this way. Now the number of electrons that have been filled up, 2 plus, 6 plus, 10 plus, how many? 14. So a total of 32 electrons have been filled up. The same, let us check whether we get the same information or not using our formula 2n square, 2 into 4 square, that is equal to 30. Okay, so 32 electrons are of course accommodated. Is that okay? So this is how I think we can just go for filling up of electrons in different orbitals. These orbitals are present in sublevels, and these sublevels are in fact present in orbits. So the root is orbits, then sublevels, then orbitals, then electrons. Now, let me also give you one more thing. How to fill up these orbitals and what is the order of filling. See, for that, I actually have to give you the methods of writing electronic configuration first. Along with the rules followed while writing electronic configuration. See, we have 3 rules that are to be followed. The first one is Aufbau. Aufbau's rule. The second one is Hund's rule of maximum multiplicity. And finally, Pauli's exclusion principle. So these are the rules that we need to follow for writing the electronic configuration of your hydrogen, your helium, your lithium, I mean the elements. Let us see what Aufbau rule says. You know, the meaning of this Aufbau is building up or to construct. I mean the order in which the electrons are filled in different orbitals. You know, to know that, we need to go for Euler's diagram. Let me first tell you what Aufbau rule is. You know, according to Aufbau, electrons first enter into the orbital having the lowest energy. Very simple, right? You need to fill up the orbital that has got lowest energy. But how to know the energies of orbitals? Now that is what I told. energies of orbitals can be known using two things. The first one is, of course, Euler's diagram. Euler. Then there is a rule called N plus L rule. Just now I told you. N is a principal quantum number. L is azimuthal quantum number. Let us see those two now. Coming to Euler's diagram. This is going to be interesting. Come on. You know, oneness. Let us just go this way. In the second orbit, we have these two. Then in the third orbit, we have 3s, 3p, 3d. See, in the fourth orbit, we have 4s, 4p, 4d, 4f. In the fifth orbit, of course, we have a 5s, 5p, 5d, 5f, even 5g is also present. But of course, we will not be using that. Then go for 6s, 6p, 6d, 6f, enough. Go for 7s, 7p, 7d, 7f. Finally, 8s, 8p, 8d, 8f. Even we don't go even this to this 8s also. Now the way it has to be filled. Check this out carefully. First enter into 1s. 1s is finished. Then slowly go to 2s. Okay. Then slowly go to 2p. Then 3s. Okay. Then go for 3p. Go for 4s. Look at this. We are not filling 3d. You need to be careful. Then go for 3d, 4p, then 5s. Again go back. Come on. 4d, 5p, 6s. Got it? Come on. Again this way. Then now it comes to 4f, 5d, 6p, then 7s. Of course, up to this it is enough. But still, if you want, I'll go for the next one also. Come on. This way.
Break.
So 5f, 6d, 7p, 8s. Enough. Let us just remove all these. So coming to the relative energies of orbitals as per Euler's diagram. Let us write this. 1s is least energetic and filled first. Then 2s. Then 2p. Then 3s. Then of course 3p. I am here now. Check out in the same order. After 3p it is 4s. Hope you can see. Then 3d. Then 4p. Then of course a 5s. Then we have a 4d. Then 5p. Then 6s. Then 4f. Then 5d. 6p. 7s. 5f. 6d. 7p. And finally 8s. I think this is very clear. So this is what I call Euler's diagram. Okay. So, you know, electrons first enter into 1s orbital because that is the one with the lowest energy. That is what our Aufbau rule says. Electron first enters into orbital having least energy or lowest energy. Okay. One last thing. You know what n plus rule says is very interesting. I told you that n is a principal quantum number and L is azimuthal quantum number. Right. Now let us check about this n plus L rule. I have two information. See if n plus L value is the least or lowest, the energy will be lowest. Let me give you one example. Let us check for 4s and 3d. I hope you all remember that 4s is filled first, leaving the 3d. I have actually shown that already. But why? Let us see even with n plus L formula. How about the n plus L for this? N is clearly visible. 4 plus L value for S sublevel is, I told you that it is a 0. So n plus L is a 4. Now come on, n value is clearly visible, 3. And how about the L value for a D sublevel? I told you that it is a 2. Check out. N plus L for 4s is only 4. For 3D it is 5. I've given the values of n. I've given the values of L also. S for S it is a 0. For P it is 1. For D it is 2. For F it is 3. You all know that. See, for 4s the n plus L value is less. For 3D the n plus L value is 5. Therefore, electrons first enter into 4s, then into 3D. Now suppose if n plus L value is same, then what? You know, if n plus L value is same, lower the value of n, lower is the energy. Very interesting. Let me give you one example even here also. Let us take 4p, I mean, 1 second, 3d, 4p, and 5s. In this case, n is a 3, L is a 2, total is 5. In this case, n is equal to 4, L is equal to 1. In this case, n is equal to 5 and L is equal to 0. See, all of them have the same n plus L value. As I said, because n value is less, in case of 3D, electrons first enter into 3D because the value of 3D is less. as it has lower n value. Electrons first enter into 3D, then into 4P, and finally into 5s, right? Of course, the same can be checked using Euler's, but Euler's, you know, every time you cannot draw that. I think this is better, right? So check this out. If n plus L value is lowest, obviously the energy is lowest. You have a very good example. But what if n plus L value is same? Lower the n value, lower is the energy. Okay, so that is all about Aufbau rule. Of course, the n plus L rule.